The generator is running. The lights are on. The refrigerator is cold. And yet, your house is becoming less safe by the hour. At first, it feels like you prepared correctly. The neighborhood is dark, but your house isn't. You can hear the steady engine outside. Inside, the refrigerator is humming. A few lights are on. Your phone is charging. Maybe the television is running in the background, filling the silence that has settled over the neighborhood. For the first few hours, the generator feels like a solution. The grid is down. You aren't. But then you look at the fuel gauge, and for the first time, you realize something uncomfortable. The generator isn't your backup power. It's a machine that needs an entire supply chain to remain your backup power. And that distinction becomes more important with every hour the grid stays down. Because during a normal outage, your generator only has to bridge a gap. The power disappears, you run the machine, the power comes back, you shut it off. The entire system is designed around one assumption. The interruption is temporary. But a grid collapse changes the question. It isn't, can my generator keep the lights on tonight? It's, can I keep this machine operating when the systems around it are no longer functioning? That's a much harder problem. Imagine the outage has now lasted through the night. Your refrigerator is still cold. The generator has done its job. You wake up the next morning and check the fuel. Nothing looks catastrophic. You still have enough. So you start the morning normally. Coffee, phone charging, a few lights, maybe a pump, maybe a freezer. And this is where the first hidden problem appears. Every device you connect to the generator feels small. A refrigerator doesn't seem like much. A few lights don't seem like much. Charging a phone barely seems relevant. But electricity has a strange psychological effect. When power is available, you stop thinking about what it costs. You begin treating electricity as a background feature of life. You turn something on because you can. And that's exactly how a limited fuel supply slowly turns into an unlimited list of demands. The generator doesn't know the outage might last for 3 days. It doesn't know fuel may become difficult to replace. It doesn't know tomorrow's water system may be more important than today's television. It simply produces power as long as you feed it fuel and keep it operating correctly. And now you're the person responsible for making all of those decisions. That means your first real resource isn't gasoline, it's judgment. You have to decide what deserves electricity and what doesn't. The freezer? Probably. The water pump? Possibly essential. Medical equipment? Potentially critical. Entertainment? Probably not. But the difficult part is that these decisions don't happen once. They happen every few hours. And as the outage continues, the cost of a mistake becomes larger. This is the first lesson most generator owners miss. A generator doesn't create energy independence. It creates temporary access to electricity. Those are very different things. Because the moment you start depending on the generator, you've created a new chain of dependencies. The first is obvious: fuel.
Your generator can be mechanically perfect and still become completely useless when the fuel runs out. And fuel storage introduces its own problems. You need enough of it. You need to store it safely. You need to manage it properly. You need to keep track of how much you've used. And you need to know what happens when you can't easily obtain more. During a short outage, getting more fuel may be inconvenient. During a prolonged grid collapse, the entire fuel distribution system may be part of the problem. Fuel stations need electricity. Fuel distribution depends on transportation. Transportation depends on functioning roads, vehicles, communications, and supply chains. Payment systems may depend on functioning networks. And the people operating those systems are dealing with the same emergency you are. So the problem isn't simply, do you have gasoline? It's, how many steps have to work before gasoline reaches you? That's a completely different question. And every extra dependency is another possible failure point. Now imagine you've made it several days. You've been conservative. You've shut down unnecessary equipment. You've reduced the generator's workload. You're feeling confident. Then the engine begins behaving differently. Maybe it needs maintenance. Maybe something has become clogged. Maybe the oil level needs attention. Maybe a component fails. And suddenly, the machine that seemed so reliable requires something you didn't think about when you bought it. Maintenance. This is one of the least exciting parts of preparedness, and therefore one of the easiest to ignore. People imagine generators as machines you store until disaster happens. But a generator isn't a fire extinguisher. You don't simply put it on a shelf and expect it to perform perfectly after months or years of sitting unused. It's an engine. Engines require fuel management, maintenance, inspection, and proper operation. And during a prolonged outage, you don't have the luxury of casually taking the machine to a repair shop. The repair shop may not have power. The technician may not be available. The required part may be sitting in a warehouse hundreds of miles away. And that warehouse may have its own supply problems. Now your backup system has developed another dependency, replacement parts. Then another, knowledge. You need to understand enough about the machine to recognize when something is wrong. You need the correct maintenance supplies. You need basic tools. And you need a plan for what happens when the generator can't be repaired. This is where redundancy becomes more important than equipment. Because if your entire power plant depends on one engine, you don't have a resilient power system. You have a single point of failure. And single points of failure are dangerous precisely because they feel reliable, right up until the moment they don't. But even if the generator remains mechanically perfect, there's another problem waiting outside your house: noise. During normal life, generator noise is an annoyance. During a neighborhood-wide blackout, it can become information. Your house is making a sound that tells the surrounding environment something very specific. Someone nearby may have power. Someone nearby may have fuel. Someone nearby may have food in a working refrigerator. Someone nearby may have medical equipment. The generator doesn't understand security. It simply announces that it's operating. And this doesn't automatically mean that every generator owner becomes a target. Real emergencies are more complicated than that, but the principle is important. Resources can become more valuable when they become scarce, and visible resources can attract attention. This creates another uncomfortable trade-off. You want the generator to run because it provides electricity, but you may not want everyone to know exactly how much electricity you have. So the generator solves one problem while potentially creating another. And now we reach one of the most overlooked issues of all. The generator needs somewhere to operate safely. You can't simply place it inside the house because you want it protected from the weather. Combustion engines produce exhaust gases, including carbon monoxide. That means ventilation and placement aren't minor details. They're life safety issues. A generator that is perfectly capable of producing electricity can become dangerous if it's operated improperly. And that leads to an important distinction. A backup system isn't useful simply because it works. It has to work safely. It has to work repeatedly. And it has to work under the conditions you actually face. Now imagine your generator is still running. Fuel is available. Maintenance is under control. You've managed the noise. You've operated it safely. But there's another problem: water. Your house may depend on electricity for far more than lights. A pump may move water from a well. Another pump may move water through a building. A pressure system may depend on electricity. Water treatment may depend on infrastructure outside your property. And suddenly,
The generator isn't just powering appliances. It's supporting another system. That system may support another one. This is what infrastructure collapse looks like when you examine it closely. It rarely happens as a single switch being turned off. Instead, one failure begins putting pressure on another. Electricity affects water. Water affects sanitation. Fuel affects transportation. Transportation affects food distribution. Communications affect coordination. And each failure changes what the others require. Your generator may keep one part of the system alive, but it can't restore everything around you. That's the trap. You can make your house electrically independent for a while without making your household independent. And eventually, the difference becomes obvious. Because electricity is only useful when you have something important to do with it. Imagine you've been without the grid for several days. Your generator has consumed fuel. You've spent time checking it. You've listened to the engine. You've calculated what appliances can run. You've worried about maintenance. You've monitored the remaining fuel. And you've had to make dozens of small decisions. Run the refrigerator? Run the freezer? Charge the phones? Power the pump? Turn everything off for the night. At some point, the generator creates another resource requirement: attention. Your backup system requires a human being to operate it, and human attention isn't unlimited. Under stress, people make mistakes. They forget. They miscalculate. They become tired. They become overconfident after several successful days. And that's when a system that worked perfectly yesterday can become dangerous today. This is why long-term resilience isn't simply about owning more equipment. It's about reducing the number of things that have to go right. If your water system requires constant generator operation, find ways to reduce that dependency. If your refrigeration needs continuous electricity, think about how you'd manage food without it. If communication depends entirely on one electronic device, consider what happens when that device fails. If your generator is your only source of power, ask what happens when the generator becomes unavailable. The goal isn't to eliminate every dependency. That's almost impossible. The goal is to understand them, because once you understand the chain, you can start breaking it into smaller pieces. Maybe you don't need to power the entire house. Maybe you only need to power a few critical loads. Maybe conserving electricity matters more than producing more electricity. Maybe your backup plan should include multiple ways to obtain water. Maybe your emergency power system should have a defined fuel budget, rather than assuming fuel will always be available. Maybe the most important question isn't, how powerful is my generator? It's, how long can my household function if this generator stops tomorrow? That question changes everything, because it forces you to think beyond the machine. Now go back to the first night. The lights are on, the refrigerator is cold, the generator is running outside. You feel prepared, and technically, you are. But preparation isn't about creating a world where nothing fails. It's about creating a system that can absorb failure without collapsing completely. That's the deeper problem with generators during a prolonged grid collapse. The machine itself may not be the weakest part. The weakness may be everything surrounding it: the fuel, the maintenance, the parts, the operator, the water system, the appliances, the ventilation, the security situation, the supply chain, the assumptions, and eventually, time. A generator can be an extremely valuable tool. It can preserve food, support medical equipment, provide light, move water, maintain communication, and make a difficult outage dramatically more manageable. But only if you understand what it actually is. It isn't an infinite power source. It isn't a replacement for the grid. And it isn't a guarantee that your household can continue operating normally. It's one component inside a much larger system, and the longer the emergency lasts, the more that distinction matters. Because in a short blackout, the generator that runs for 12 hours can feel like freedom. In a prolonged collapse, the same generator can become another system you have to feed, maintain, protect, monitor, and eventually replace. That's why the most resilient backup plan isn't built around one impressive machine. It's built around layers. A way to produce some electricity, a way to conserve it, a way to obtain water without relying entirely on electricity, a way to preserve food when refrigeration isn't available, a way to communicate when normal networks fail, a way to maintain essential equipment, and, most importantly, a way to keep functioning when one of those layers disappears. Because the real measure of preparedness isn't how much power you can produce when everything goes wrong. It's how little your entire life depends on any single thing continuing to work. The generator is still running. The lights are still on. But now you understand what you didn't see at the beginning. The machine was never the entire solution. It was only one link in the chain. And when the grid collapses, the question isn't whether you have backup power. The question is how many other things have to keep working before that backup power actually keeps you safe.